You know, for years, the absolute gold standard of building software has looked pretty much fundamentally identical across the entire
Oh,
industry.
yeah. The classic waterfall, basically.
Exactly. You'd map out every single edge case in this like massive prototype. You'd spend weeks agonizing over, you know, corner radii and padding in a design tool.
Pushing pixels forever.
Great. And eventually, after countless review meetings, you hand off this pristine static masterpiece to an engineering team.
Assuming they could even build it.
Which, let's be honest, was always a coin toss.
Mhm.
But I have a really provocative thought for you today, if you're listening to this. That traditional design process, it is officially dead. It is completely over.
Just gone.
And what's replacing it isn't just a faster version of the old way. It is dynamically generated, it's totally fluid, and it's fundamentally changing what it actually means to build a product from the ground up.
It's a complete architectural collapse of the old way of doing things. I mean, we are shifting away from static blueprints entirely.
We really are. We're moving toward these living, breathing interfaces that essentially design themselves in real time based on context.
It's wild to even think about.
It is. Well,
Coming to you, live from the turning point of history at Beskar.
welcome to AI Deep Dive with Beskar, Episode 6, Future of Design and Product Engineering. I'm your host, Amy, and I'm joined by our expert, Adam.
It's fantastic to be here for this one. The sheer velocity of change we're about to discuss is, well, it's staggering.
It really is staggering. Now, for those of you listening, after our last two highly focused deep dives, this episode serves as a broad landscape overview.
Right, we're taking a step back today.
Exactly. We are zooming out to look at exactly where design and engineering are heading in this new era. And before we get into the weeds of tokens and plain text wireframes and generative UI, just take a second to subscribe to our channel.
Please do, it really helps.
Yeah, so our team knows you are interested in this specific type of high-level architectural content. Your support genuinely helps us keep these deep dives coming.
Absolutely. And
Okay.
to truly understand where the software industry is going, we can't just, look at the code.
No, you have to look at the people.
Exactly. We have to look at the human element first. Because before we even touch on the fascinating new tools that are building this future, we need to acknowledge how the role of the designer itself has fundamentally fractured.
And evolved over just the last several months. It's crazy.
I know, completely. The psychological shift for people in the industry right now is massive.
It really is. We were looking at some incredible insights from Jenny Wen, who is the head of design at Claude. She was recently on Lenny's podcast, and she basically said the old gospel of the design process is dead.
Yeah, that classic, discover, diverge, converge.
Right. Trust the process. The mantra they teach in, like every design boot camp, it's just dead.
The statistics she provided really contextualized the death of that old process, too. She pointed out that just a few years ago, maybe 60 to 70% of a designer's daily job was mocking and prototyping.
Drawing the boxes.
Drawing the boxes, connecting the screens, making sure the drop-down menu had the exact right hover state. Today, that's down to 30 to 40%.
Wow.
Yeah. The ground has entirely shifted beneath their feet.
And when you pause to think about why that shift happened, it's wild. It isn't that designers across the globe suddenly decided they didn't like prototyping anymore,
No, not at all.
or that user research became less important. Engineering velocity is the real culprit here. They are forcing design's hand.
Oh, without a doubt.
Jenny Wen noted that engineers are moving at absolute light speed right now. They're utilizing, as she put it, 7 AI agents simultaneously.
7 agents at once. That is the crux of the issue right there. Imagine you're a designer trying to follow the traditional process. You're setting up your artboards, gathering your color palettes, preparing for a sprint planning meeting.
Getting your little sticky notes ready.
Exactly.
Yeah.
Meanwhile, the engineer next to you has spun up 7 AI agents that have already written the boilerplate code
Generated a functional database schema.
and stood up a live, clickable prototype right in the browser. They aren't waiting for a mock-up anymore. They are already testing the logic.
Right. So the new mandate for design, essentially, is to let the engineers cook.
Let them cook.
You cannot block the highway with a wireframe toll booth when the engineers are driving a bullet train. You have to get out of the way of the implementation.
Which forces designers into doing what the industry is now calling last-mile work.
Last mile work. I love that term.
Because the AI and the engineers get the product to 90% completion so rapidly, the designer's role transitions into consulting, polishing.
Jumping directly into the code base, right?
Yeah, jumping in to tweak CSS or adjust the layout. They are helping engineers execute the final vision rather than handing off a pristine, pixel-perfect mock-up at the very beginning of the cycle.
I want to synthesize this into a concept for you listening right now because this is crucial.
Yeah.
If we look at this evolution, the conclusion we're arriving at here at Beskar is pretty stark.
It really is.
In this new paradigm of software development, you're essentially one of two things. You are either a generalist who builds or a domain expert who reviews. Because of that, product requirements documents the classic PRDs are dead. Implementation is cheap. Taste and review are the real bottlenecks now.
That is a massive paradigm shift. I mean, think about the historical context of a PRD. Teams used to spend thousands of hours, sometimes literally months, just writing and arguing over PRDs before a single line of code was ever written.
Oh, the endless comment threads on a Google Doc.
Exactly. And why did they do that? Because engineering time was incredibly expensive.
Right.
If you built the wrong thing, you wasted hundreds of thousands of dollars. The PRD was an insurance policy against expensive mistakes.
But if implementation is cheap, if an AI can generate the feature in like 10 minutes, that entire insurance policy becomes completely obsolete.
Totally obsolete.
Why spend 3 weeks documenting what a feature should be in a text document when you can just prompt an agent to build it, look at the actual functioning software, and then review it?
Exactly. The cost of being wrong has plummeted to near zero. You just iterate. You build it, you look at it, you say, no, that's not quite right, adjust the data flow, and you generate it again.
The bottleneck shifts entirely away from the physical labor of writing code or drawing pixels.
Right. It lands squarely on human taste, human judgment, and human curation.
It reminds me of the dynamic at a major publishing house. The designer is no longer the author sitting alone in a room staring at a blank page. The AI and the engineers are writing the rough draft.
They're generating the bulk of the content.
Yeah, and the structural foundation. The designer is now the senior editor. You are the tastemaker. You step in to refine it, to ensure the pacing flows perfectly, to cut the fluff, and to give it that final market-ready polish.
And because the job has changed from pure creation to curation and refinement, we are seeing the emergence of entirely new hiring archetypes in the design world.
Oh, this part is so interesting.
You aren't just looking for someone who knows every keyboard shortcut in traditional design software anymore. The sources highlighted 3 very distinct archetypes that forward-thinking companies are hunting for right now.
The first one is the strong generalist, which the industry is referring to as the block shape.
Right, the block shape.
This is fascinating because it goes against the old advice of finding a niche. The block shape is someone who is consistently in the 80th percentile across a massive variety of skills.
They do a little bit of everything.
They understand UX, they understand visual design, but they probably also know basic coding, system architecture, and prompt engineering. They can flex wherever the AI needs a human hand.
They are the ultimate pragmatists. They don't care about the purity of the design process. They just care about shipping functional software. Then on the other end of the spectrum, you have the deep specialist, or the deep T-shape.
Right, the person who is in the top 10% of the industry for one highly specific, incredibly complex thing.
Precisely. Because when an AI can build 90% of the basic UI instantly, you know, the login screens, the settings panels, the data tables, the
Hovering stuff.
Exactly. You don't need humans for that anymore. But you absolutely need a human specialist for the deeply complex, highly nuanced edge cases.
Like what?
Think about a custom data visualization tool for a proprietary financial algorithm, or a spatial computing interface for medical imaging. The AI cannot invent that from scratch reliably. You need that top-tier specialist to guide the machine through the bespoke complexity.
And the third archetype, which I personally find the most interesting, is the craft new grad. This is essentially a blank slate.
Tabula rasa.
Yes, they don't have 10 years of the old way deeply ingrained in their muscle memory. They don't mourn the loss of the traditional PRD or the months-long discovery phases because they never lived through them.
Ignorance is bliss, right?
Truly. They are just eager to learn, they aren't precious about how things used to be done, and their baseline expectation is that they will build products using the absolute newest AI tools available.
They are completely unburdened by legacy workflows, which makes them incredibly fast.
It does. Which brings up a really provocative question for you listening to this right now. Have you felt your own role shifting recently from creator to editor? Have you felt that transition from drawing the initial lines to critiquing the generated output?
Yeah, it's a tough transition for a lot of people.
And if so, is it liberating to not have to build everything from scratch? Or does it feel like you are losing control of your craft? It is a heavy psychological shift to wrestle with.
It's a profound shift in professional identity, and it naturally leads us to ask a very practical question. If implementation is now so cheap and designers are transitioning into these reviewer and tastemaker roles, what are the actual tools making this rapid implementation possible?
Because it certainly isn't the heavy, traditional design software that dominated the last decade.
Oh, definitely not. We are witnessing a massive migration away from those legacy platforms. The entire tool stack for product teams is getting a major overhaul. We're talking about a fundamental shift toward tokens, text, and connected canvases.
To understand why this shift is happening, we really need to look at the underlying physics of how large language models interact with design files.
I'm so glad you brought this up.
Yeah, because this is where the Beskar editorial view really crystallizes. Traditionally, we used to design product requirements in a tool like Figma. More recently, as AI entered the chat, people started using Claude to design with Figma.
Right, trying to bridge the gap.
They'd take a Figma file, feed it to the LLM, and ask it to write the code. But even then, what we've noticed is that Figma generates the HTML and different assets and then converts them to Figma native formats. This process takes up quite a lot of tokens.
It is incredibly inefficient for an AI. When you think about what a traditional design file is under the hood, it is not web code.
No, not at all.
It's a massive proprietary JSON tree, plotting absolute coordinates for every vector, every shadow, every layer, and every grouped frame.
Right. If you draw a simple blue button in a legacy design tool, the software doesn't just say blue button. It outputs hundreds of lines of proprietary data about the X and Y axis, the corner radius rendering logic, the canvas positioning.
It's bloated.
Totally bloated. When you hand that massive file to an LLM, you are forcing the model to spend a huge chunk of its context window, its active brainpower, just translating those proprietary visual coordinates into a mental model of a web page.
You are burning tokens on translation, not on generation. And tokens are the currency of AI. If your design tool is eating up your context window just trying to render proprietary file formats, your AI has significantly less cognitive capacity left to actually build the business logic.
To understand the user flow.
Exactly. And to write efficient code.
Which perfectly explains why the new set of tools we are seeing, platforms like Paper, Pencil, or Bait, are so revolutionary. They use 50 to 70% fewer tokens because they generate the UI natively based on LLMs right from the start.
They completely bypass that heavy translation layer.
And this is exactly what we're building towards. One of the ideas we've been working on at Beskar is to develop Bait Design, which generates generative UI from LLM prompts and allows users to design front-end applications with LLM decision points in mind.
It's native to the medium.
Right. And on the other hand, there are tools like Mockdown Design that allow users to create UI mockups through generative AI, leaving the output in plain text. That plain text can then be fed to LLMs, which better understand it and can generate the actual UI.
Let's actually look at a tool like Paper for a second. It's an entirely new kind of environment. It's described as a connected HTML and CSS canvas that syncs design tokens directly with your agents and your code bases.
Okay, I want to make sure we really unpack this for you listening. When we say connected canvas, what does that actually mean for the workflow?
It's a complete shift.
Let's say I'm a designer using Paper. Instead of designing a button on a blank digital whiteboard and hoping the developer codes it to look exactly like my picture, what is actually happening on the screen?
What is happening is that the canvas itself speaks the native language of the web. It isn't a picture of a website. It is the website. When you design in Paper, it is connected bidirectionally to your actual code base.
Yeah.
If an AI agent updates a component in the code repository, say it changes the padding on all the buttons that change, instantly reflects on your visual canvas.
Instantly.
Yes, and conversely, if you as the designer click and drag to tweak the layout on the canvas, the agent automatically pushes that CSS change back to the code. There is zero translation loss.
That is just mind-blowing. The concept of handoff is completely eliminated. The design is the code, and the code is the design.
Exactly.
And Paper isn't the only tool doing this. There is also Pencil, which takes a slightly different but equally fascinating approach. Pencil is an agent-driven MCP canvas.
And we should clarify what MCP means here because it's becoming a critical standard. MCP stands for Model Context Protocol.
Right.
It is essentially a secure, standardized pipeline that allows an AI model to safely read your local file system, understand your specific codebase architecture, and see your local environment.
Without you having to manually copy and paste code snippets into a web browser window every 5 minutes.
Exactly. It gives the AI a VIP all-access pass to your project, but in a highly secure, structured way. And what is crucial about Pencil is that it puts this visual canvas exactly where the code lives, right inside your integrated development environment, like Cursor or VS Code.
It embraces this wild idea that AI single player is the new multiplayer. You don't need a massive team of human developers crowding around a file.
You really don't.
You have a crew of specialized AI agents acting as extra hands, generating screens or entire user flows in parallel right beside your code editor. You can literally highlight a piece of React code, click a button, and say, show me what this looks like visually, and let's tweak the margin.
And as you adjust it visually, it writes the code updates live.
It is the ultimate collapse of the boundary between visual design and software engineering. But as advanced as paper and pencil are, there is another tool in this new stack that I find even more conceptually fascinating.
Because it seems to go in the exact opposite direction.
Exactly. I'm talking about Mockdown.
Yes, Mockdown. It is a free ASCII wireframe editor. It lives entirely in plain text and markdown formatting.
Okay, I have to push back here. We just talked about bidirectional, code-aware visual canvases that render live CSS inside your IDE. Why on earth would any modern product team go backward to ASCII art and plain text?
I know, it sounds crazy.
It feels like stepping out of a state-of-the-art spaceship and deciding to ride a horse to work. You are literally making boxes out of dashes and brackets.
It sounds completely counterintuitive on the surface. But when you understand the token optimization we discussed earlier, the brilliance of Mockdown becomes obvious. The reality is that AI models, specifically their neural networks, read Markdown infinitely better than they read human natural language explanations.
And vastly better than they read image files.
Exactly. Let me see if I'm following the logic. If I spend 10 minutes typing a prompt that says, put a search bar on the top left, put a data table below it, make sure there's pagination at the bottom, and put a user profile avatar in the top right, the AI might still get the spatial layout completely wrong, because language is ambiguous.
Right. Natural language is terrible for describing spatial relationships.
Precisely. But if you give the AI a visual ASCII layout, literally drawing the interface using keyboard characters and plain text, it understands the spatial relationship immediately. It can see the structure perfectly.
Because to an LLM, plain text isn't picture, it's just tokens. You are speaking the machine's native language.
Exactly. Neural networks process text via tokenization. An ASCII wireframe costs maybe 100 or 150 tokens to process. A high-fidelity image or a complex proprietary design file might cost thousands. Mockdown exports clean, structured Markdown that tools like Claude Code or Cursor understand perfectly on the very first try.
And beyond just the token math, I imagine keeping the wireframe in lo-fi text keeps the human conversation focused on the right things.
How so?
If you are reviewing a plain text wireframe, you are arguing about structure, hierarchy, and user flow. You aren't wasting an hour debating what shade of blue the button should be, because there is no blue.
That's a great point. It forces structural alignment before aesthetic polish. But there's a missing link here that we really need to address.
Okay, what's that?
We've covered how the software development lifecycle has changed, turning designers into reviewers. And we've explored this highly efficient, lightweight tool set, the canvases and the plain text editors. But if an AI is going to actually generate production-ready code inside these tools, it needs a framework. It needs to know what it is legally allowed to use.
That is such a critical point, because if I tell an AI agent to build a user settings page, I do not want it hallucinating some random generic button styles from a 2014 Bootstrap tutorial it memorized during its training phase.
Nobody wants that.
I want it to use my company's specific buttons. I want it to use our brand colors, our specific typography, our exact input fields. The AI needs constraints. It needs what the industry is calling skills.
And this brings us to the explosive rise of component libraries, and specifically the dominance of shadcn. If you're building modern web applications right now, shadcn has essentially become the gold standard.
It has a near monopoly as one of the best component libraries available.
It really has taken over.
But how does it bridge the gap between a generic LLM and a highly specific company brand? How do these skills actually work in practice?
They recently introduced a mechanism to give AI assistance, like Claude Code, deep project-aware context. It revolves around a file in your project directory called components.json.
Okay, let's unpack the mechanics of that. What is a components.json file actually doing when the AI reads it?
Think of it as a Rosetta Stone for the AI. When the AI skill reads this file, it instantly learns the exact rules of your specific project.
Like what kind of rules?
It learns which framework you are using, say Nest.js. It learns which version of Tailwind CSS is installed. It learns your custom path aliases so it knows exactly where to look in your folder structure to find a file.
Right.
And most importantly, it learns exactly which UI components you have installed and approved for use.
So it's basically giving the AI the employee onboarding handbook, the brand guidelines, and the strict engineering rules before it ever writes a single line of code.
Yes, exactly.
The AI knows, okay, I am not allowed to invent a drop-down menu. In this project, we use the specific Radix-3 base library, we use these exact semantic color variables, and we use this specific drop-down component.
It completely eliminates UI hallucinations. It forces the AI to follow the company's specific design system architecture. If you prompt the agent to create a dashboard with a data table and a filter dropdown, it won't invent the CSS. It will automatically pull your company's table component, your select component, and assemble them using your approved spacing variables.
Let me pose a question to you listening. Would you actually trust an AI to automatically pull from your company's design system without breaking your carefully protected brand guidelines?
It's a scary thought for a lot of design leads.
Historically, design systems were policed heavily by human design ops teams to ensure nobody used the wrong shade of gray. Letting an autonomous model assemble your highly protected brand assets requires a massive leap of faith.
It does require trust to make that initial leap, but what teams are discovering is a fascinating paradox. Providing these strict boundaries, these skills, actually gives the AI more freedom to be accurate.
How so?
When you constrain a large language model to only use a set of pre-improved components, you eliminate the infinite variables that cause the model to guess or hallucinate. By restricting its choices, you guarantee its output. Constraints breed confidence.
Constraints breed confidence. I love that phrasing. And this lines up perfectly with how our team is analyzing the broader landscape. If we synthesize everything we've discussed so far, here is a Besker view on this evolution.
Let's hear it.
First, we talked about how the software development lifecycle has fundamentally changed with LLMs, moving us from PRDs to real-time review. Next, we talked about all the different tools available, such as paper, pencil, Bade design, and so on. Now the topic is component libraries and skills.
Right.
shadcn has a near monopoly as one of the best component libraries. They also provide skills similar to Bade skills. These are different ways of telling your LLM to generate a particular kind of UI.
The constraints we just talked about.
Exactly. The toolset was discussed earlier through paper, pencil, and Bade. If you take the skills, all these component libraries, and the tools, and put them into production where decision points are made in real time, what you get is a generative UI.
And there it is, the absolute holy grail of modern product engineering, generative UI.
It's what all of this has been building towards.
Because this isn't just about AI helping a developer write React code faster in their IDE. That's just an efficiency game. Generative UI is about the application interface itself, adapting, morphing, and responding to the end user in real time.
To define it clearly for the listener, generative UI is the death of the one-size-fits-all screen. It's the replacement of static, hard-coded dashboards with dynamic interfaces that shift entirely based on user intent, user data, and immediate context.
The interface you see on your screen might look entirely different from the interface I see on my screen, even though we are logged into the exact same application at the exact same time.
This concept really hit the mainstream consciousness recently with Google's Gemini 3 announcement, which showcased some incredible dynamic interfaces. But the underlying infrastructure making this possible, the plumbing that actually makes the UI shift, is incredibly complex.
It really is.
The sources we reviewed pointed to a project called OpenUI, which is built by a company called Thesis. They recognized a massive bottleneck in how AI was trying to render interfaces.
Yeah, they realized that relying on JSON to generate user interfaces was a complete nightmare for large language models.
Wait, let's break that down. Why does an LLM choke on JSON? JSON is just a standard data formatting structure. Developers have used it for years to pass data back and forth. Why does AI struggle with it?
Because JSON requires absolute mathematical structural perfection. It is incredibly rigid and verbose.
Right.
If an LLM is generating a massive JSON payload to describe a complex UI, and it hallucinates or misses one single closing bracket or forgets one comma on line 400, the entire JSON schema becomes invalid.
Ouch.
Yeah. The parser throws an error, the application crashes, and the UI completely fails to render. LLMs are probabilistic text generators. Expecting them to flawlessly generate massive, perfectly nested JSON trees every single time is fighting against their very nature.
That makes total sense. You're asking a creative engine to act like a strict calculator. So OpenUI moved away from JSON entirely. They shifted to a code-like syntax that LLMs actually understand natively and intuitively.
Because code-like syntax like HTML or JSX is inherently more fault-tolerant and aligns better with how the models were trained on millions of GitHub repositories.
And the results of dishing JSON are staggering. Thesis reported 3x faster rendering speeds and 67% fewer tokens used.
It all comes back to token optimization. Everything is connected.
It always does. If the model isn't struggling to close brackets in a JSON tree, it can focus on generating the UI faster. And on the implementation side of things, we are seeing the rise of tools like Tambo AI. Tambo is an open-source generative UI SDK specifically built for React.
Right. It solves the problem of how to actually get the AI's thoughts onto the screen smoothly.
Because historically, you'd ask a chatbot a question, and you'd have to sit there and watch a little loading spinner while you waited for the whole payload to finish generating before the UI updated.
So annoying. But Tambo allows AI agents to stream properties directly to the React components on the screen. As the AI is generating the response token by token, the UI components are actively morphing and populating with data.
So users can interact with the charts or forms immediately without waiting for the entire generation cycle to finish.
Exactly. So instead of waiting for a chatbot to type out a massive paragraph explaining your monthly sales data, the AI just streams the data directly into a dynamic bar chart component in real time, and you can instantly hover over the chart to see the details. It is incredibly fluid.
And as this streaming generative UI technology matures, the industry is beginning to categorize the user experience into 3 distinct application surfaces: chat, chat plus when, and chatless.
Let's unpack those 3 layers. We all know the first one. Chat is your standard threaded interaction. This is the ChatGPT experience.
You're right. You type a question into a text box, you hit enter, and you get a response. Maybe, if it's advanced, an interactive widget or card pops up inside the chat feed itself.
Correct. It is conversational, but it is linear. Then you move to the next evolution, which is chat plus lane. This is fundamentally a co-creator workspace.
Think of having your standard conversational chat window docked on the left side of your screen, but on the right side you have a large, open canvas. As you chat with the AI on the left, the agent generates and continuously updates a massive spreadsheet or a complex text document or a rich dashboard on the canvas to the right.
You're working side by side with the AI.
It's like having an incredibly fast intern sitting next to you. You give the instruction and you watch them do the work on the big monitor. But then there is the ultimate form, the final destination, chatless.
This is where the friction completely disappears.
Exactly. In a chatless interface, the UI adapts natively directly inside the standard application screens without a chat box anywhere in sight. You don't have to prompt the app. The app just knows what you need based on your context, and it rearranges its own panels, buttons, and dashboards to surface the exact tools you need at that exact second.
And this brings us directly to our final and perhaps most important editorial takeaway of this deep dive. Here's the Beskar view on the ultimate destination of generative UI.
And this is a deeply interesting topic because we can now generate UI based on data changes or user type and so on.
Give us an example.
For example, we could push out a mobile app for a game, like a live sports game, and display a particular widget based on the game's scoring.
Oh, that's smart.
Generative UI opens up an interesting option. We can use an LLM to decide which UI widget to present to the user based on their profile, attributes, or other available data. In the past, we could only do this through hard-coded logic or decision points. Now we can use an LLM for those decision points.
The core of the revolution.
But okay, I have to push back on this concept of chatless shape-shifting interfaces. If an LLM is acting as the router, if the app is constantly rearranging itself based on what the AI probabilistically thinks I want, don't we completely lose the muscle memory of using an app?
That's a valid concern.
Like, if I log into my banking app and the transfer funds button has moved from the top right to the bottom left because the AI decided I am focusing on a different task today, I'm going to be infuriated. Humans rely on spatial predictability.
That is the absolute critical tension in generative UI right now. It's the balance between hyper-personalization and necessary predictability. But the goal of chatless UI isn't for the AI to invent entirely new, confusing widgets on the fly and scatter them randomly across your screen.
It's not chaos.
Right. It goes right back to the component skills we discussed earlier with shadcn.
The constraints.
Exactly.
Yeah.
I like to think of it less like a room that constantly changes shape and more like a highly efficient stage crew during a theatrical play. The props, the approved component library, the strict design system are all safely stored backstage. The AI is simply the stage manager.
Oh, I like that analogy.
It doesn't build new props. It just slides the exact right prop onto the stage at the exact moment the actor needs it,
Mm.
and then quietly removes it when the scene is over.
That is a phenomenal analogy. So the human designers and engineers still create the overarching framework, the boundaries, and the master component library. The AI is just deciding which of those pre-approved, highly polished components to surface based on the immediate context.
Exactly. If implemented correctly, a chatless interface shouldn't break your muscle memory or feel disorienting. It should simply feel like the application is intelligently clearing away the cognitive clutter and the menus you didn't need anyway, leaving only the tools required for the task at hand.
It's controlled shapeshifting. It anticipates your needs without violating the laws of the design system.
Exactly. And that is why the role of the designer isn't dead. It is just elevated. They are the ones building the props and setting the rules for the stage manager.
Well, this has been an absolutely incredible journey through the rapidly shifting landscape of product engineering. To wrap this up for you listening, let's quickly recap the 4 major practical takeaways from everything we have unpacked today.
Let's do it.
Number 1, embrace the role of the reviewer. As we discussed, the traditional PRD is dying out, implementation has become remarkably cheap, and your ultimate value to a team is now anchored in your taste, your judgment, and your curation.
Number 2, relentlessly optimize your token usage. Start moving away from heavy, legacy design platforms that burn context windows on proprietary formats. Explore AI-native tools like Paper, Pencil, Bade, and even ASCII-based plain text tools like Mockdown to speak the machine's native language.
Number 3, equip your AI agents with specific component skills, whether that's using shadcn or Bade skills. Give the models strict, unyielding boundaries so they can generate confident, on-brand code without hallucinating rogue UI elements.
And number 4, prepare your architecture for generative UI. We are rapidly moving toward an era where LLMs act as the intelligent routing layer, making real-time decisions about what widgets and interfaces to show the user, adapting to their specific context instantly without relying on hard-coded logic.
Which leaves us with one final, lingering question for you to ponder long after this audio stops playing.
This is a big one.
If AI dynamically generates a completely custom shape-shifting interface for every single user, does the concept of a shared user experience cease to exist entirely?
It's a real philosophical dilemma.
Think about it. How do we talk about an app around the water cooler or write a step-by-step tutorial for a piece of software when your version of the app looks completely different from mine?
That is going to be a massive, fascinating challenge for the industry to solve over the next few years.
It really is. Thank you so much for joining us for this landscape overview. This has been AI Deep Dive with Beskar. Don't forget to hit that subscribe button so we know to keep bringing you this level of in-depth analysis. We will see you in the next Deep Dive.